Hello everyone, at this part we're going to introduce the principles of wireless hot backup. And firstly, let's see the background of it. The wireless communication depends on access controllers because ACs or access controllers manages all the APs in the network. And at the same time, in the centralized forwarding modes, all the traffic should go through AC. So it's playing a quite important role. When an AC is faulty, communication between an SDA and the external network through the AC will be interrupted. So by using the wireless hot backup function, it will switch the backup terminal within milliseconds for an AP associated with the AC. In this way, we can ensure the availability and the stability of STAs. This is an advantage of it, while at the same time it has some disadvantages. And the first disadvantage is that we need at least two ACs in the network, right? It will increase the cost of the network. And of course, the configuration will be a little more complex. Okay, after knowing the background, then let's take an overview of the working process. When everything is working normal, you can find we have two ACs, AC1 and AC2. Actually, there would be an election between them. AC1 will be the master, we assume that, and AC2 will be the slave. So AP will establish the backup terminal with both of them. And the backup terminal between the AP and the master AC is an active backup terminal, while the other one is a standby backup terminal. And between the master AC and slave AC, they should establish a hot backup keep live channel. And in this channel, they will exchange some information. And actually, they will monitor the running status of each other. And when the AC1 is 40, since AC1 is a master, so if it's 40, AC2 will become the new master of the network because AC2 will detect the 40 of AC1 through the keep live channel. And once find that AC1 is 40, AC2 will become the master. And of course, the backup terminal between AP1 and AC2 will become the active backup terminal. All the traffic will go through the active backup terminal in this figure, right? The terminal between AP1 and AC2. Okay, in this way, we have prevented interruption of the network, right? While when the AC1 is recovered, actually it depends. By default, you can see even when AC1 is recovered, AC2 will still be the master, and all the traffic will go through the terminal between AP1 and AC2. But in some cases, if we adjust the priority of the AC1, for example, the priority is 7. So when the AC1 is recovered, it will take place and it will become the new master. And AC2 will become the slave again. Okay, so we can see that it depends, and what you can see in this figure is a default scenario. Okay, and this is the overview of the process, and then let's see the details. Here, the two ACs, first they will determine the master and the slave through negotiation, and they will establish a keep live channel to maintain the communication between each other. And AP established an active backup terminal with a master AC and a standby backup terminal with a slave AC. The user communicates with the external network through the active backup terminal between the AP and the master AC. This is the status when everything is working normal, while when the AC is 40, in this case, AC1 is 40, right? It's a master AC. So the slave AC detects that the keyblab packet times out and notifies the AP. The standby keep terminal between the AP and the slave AC is activated, and the slave AC will become the master one. Services of users are restored after the standby terminal is activated. Okay, this is a situation when the master AC is faulty, while when the master AC recovers, it will re-establish the hot backup with the new master AC and becomes a slave AC. You can see it's a slave right now. And the AP establishes a standby backup terminal with slave AC. Services of users are not interactive anymore. Of course, it will not affect the terminal between AP1 and AC2. Okay, this is a working process of the wireless hot backup. And the wireless hot backup have two different working modes. The first is AA mode. The reason why we call it AA mode, you can see the figure. Now we have two ACs, AC1 and AC2. Well, what's different between we have introduced is that AC1 is a master and AC2 is also the master. So in the AA mode, both ACs provide services and both of them are masters. Some APs select AC1 as a master AC. For example, in this figure, AP1, right, select AC1 to be the master. And other parts of AP select AC2 as a master, for example, AP2, right? Okay, this is called the AA mode. Both ACs are active. And the other one is the AS mode. From the name, we know that AS means active and standby. The figure is the same. We have two ACs, AC1 and AC2. While AC1 is a master, AC2 is a slave. And actually, it's the same as what we have just introduced during the working process. Right? Both AP1 and AP2 will select AC1 to be the master, and they will establish the active backup terminal with AC1, right? And of course, they will establish the standby backup terminal with AC2. Okay, AC2 will not process any service; it's just the standby. Okay, so compared between the AA modes, the AS modes have a shortage. Is that AC2 or the slave AC will not process any service. So in some scenarios, when the traffic in the network is heavy, we think that the AS mode could have some bottlenecks. Okay, this is about the working modes. Okay, after introducing the principle of the wireless hot backup, here let's see a question. Here is a statement. AA mode is more suitable for the scenarios when the network traffic is heavy. You think it's true or false? Actually, obviously it's true, right? Because in the AA mode, both ACs will process services, right? So it can reduce the workload of one specific AC, right? So, and it can prevent the bottleneck occurs in the network. Okay, that's all for this part.